Welcome to Math Challenge 366. In Math Challenge 366, we are given a quadrant, that is a quarter circle. A quadrant or a quarter circle of radius 1. The radius of the quadrant or quarter circle is 1. And inside we have a circle which touches the two radii and the circumference, or the arc I should say, the arc of the quarter circle and the two radii. We have a circle and we have to find the radius of this circle. So what we have? A quarter circle or a quadrant of radius equal to 1 unit. Inside we have a circle and we have to find the radius of the circle. So let us see whether we can do it. Math Challenge 366. Follow us for Olympiad exams, school exams, competitive exams, and aptitude tests. So here we go with Math Challenge 366. Now from the center of the circle, full circle, draw the radii perpendicular to the tangents. The radii of the quadrant are actually tangents. The 1 unit radii, the two radii of the quadrant circle are actually tangents for the full circle. So from the center of the circle, draw the two radii perpendicular to the tangent, and because radius is always perpendicular to the tangent, you will get a square, right? Each of them is a radius r and all these are perpendicular 90 degrees. So what you are getting is a square. So you are getting a square of side r. Right, what we have done from the center, see the blinking lines, we have drawn the two radii perpendicular to the tangent, which is radii of the quadrant, and because the radius is perpendicular to the tangent in both the cases, we have got a square. Each side of the square is r. So after we get the square, now we proceed further. Now draw the diagonal of the square. See the blinking line. What we have drawn? The diagonal of the square, and if the side of the square is r, the diagonal will be root 2 times r. The side of the square is r, so the diagonal of the square will be root 2 into r. You can also take this right angle triangle, and by Pythagoras theorem, r square plus r square will be 2r square, and the square root will be root 2 times r. So we get the diagonal of the square as root 2r. Now let us see the next step. Now extend this diagonal to the point x. We already got the diagonal. From this center of the circle, extend this diagonal to touch the arc, so that what you are getting? An OX. Now in this OX, till this diagonal, it is root 2r, and from the center to x, it is a radius. From O to the diagonal part, that is a diagonal of the square, it is root 2r, and from here to the point x is r, because there is a radius. So the total line OX will be root 2r plus r. This is root 2r, the diagonal, and this is the radius r. So the total length of the line OX will be root 2r plus r. So we got OX equal to root 2r plus r, but OX is the radius of the quadrant. OX is the radius of the quadrant, which is equal to 1 unit. So OX being the radius of the quadrant is equal to 1. So we can say root 2r plus r is equal to 1. Right? This is root 2r and this r, and the total OX is the radius of the quadrant, which is 1. So root 2r plus r equal to 1, or take out r as common, that is r into root 2 plus 1 equal to 1. So r will be 1 divided by root 2 plus 1. We rationalize by multiplying with the conjugate. Multiply this fraction, numerator and denominator, with the conjugate, that is root 2 minus 1. So numerator you get root 2 minus 1, denominator root 2 plus 1 into root 2 minus 1, that is root 2 whole square minus 1 whole square, that is 2 minus 1 or 1. So root 2 minus 1, that is the value of r. So the required radius is root 2 minus 1, and if you want you can put the value root 2 equal to 1.414 minus 1, that is 0.414, or you can leave it as root 2 minus 1. So what we got, OX, which is root 2r plus r, is equal to 1. Taking out r common, root 2 plus 1 times r equal to 1. So r equal to 1 by root 2 plus 1. Then we rationalize, we multiply the numerator and denominator by root 2 minus 1, that is a conjugate, and we get root 2 minus 1 by 1. So root 2 minus 1, root 2 minus 1, yes, units, that would be the required radius of the inside circle.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.